Okay, so it's the fourth video. Measuring air pressure. We can find air pressure of our atmosphere by comparing the column of air that creates our air pressure with a column of another fluid. Okay, in other words, if we had a column of air at a certain height, at the bottom that would create some sort of pressure. Now, if we put that into a tube, we could actually put in another type of fluid, like a liquid, and that would also have the same pressure at the bottom if the fluids were balanced. I'll show you what I mean once we've done this. What height will a column of water be to create a pressure of 10 to the 5 pascals? In other words, 1 atmosphere. Okay, so height equals, actually no, we'll do it the long way, make it easier. So pressure equals rho GH, so the equals density of water is 1,000 multiplied by gravity multiplied by height is equal to 100,000. So if you work all that out, the height is around about 10 meters. So 10 meters of water gives you the same pressure as our whole atmosphere, the height of our atmosphere. So if we were going to use a scale, we could use a water tube, okay, and we could compare the atmospheric pressure with the height of water in a tube. Now it wouldn't be very portable because the height of the water in the tube would be about 10 meters, okay, so it would not be a very portable one. So what you can use though is something like mercury, which is a very dense liquid, and the column of that would be 0.76 meters. So the air pressure pushes down on the mercury reservoir, raising the height of the mercury up the tube. Once the pressure at the bottom of the mercury column matches the air pressure, it will stop. In other words, if you think about this, we have a column of air here pushing down. At the top of the column there's a vacuum of space. Okay, this air is pushing down with a certain pressure. Now the pressure along the bottom here has to be the same for both the mercury or the air. Otherwise the mercury could push into the air, or the air could push the mercury into the mercury. Okay, so the air pressure and the mercury pressure are the same at the bottom. So what height mercury creates that? Well, it's just this height up this tube, okay, and that is around about 76 centimeters or 760 millimeters. Oh, you could work that out. These are other ways of doing it. This is a cell that will be pushed on by atmospheric pressure, and this is how essentially your barometer works. Okay, so your barometer measures air pressure. Your air pressure changes depending on if it's a high or a low. You might see them on weather maps. And what you actually look for is a rapid change in the barometer. And the rapid change will tell you that something is happening. A similar principle of the barometer can be used to apply to measure the pressure of a fluid flow. Okay, in other words, the faster things flow, the lower the pressure. Okay, that's actually Bernoulli's principle. It's essentially its principle behind flight and so on. For this we use a manometer, which essentially is just a tube. Okay, if you have air flowing past this part of the tube, okay, it will create a certain pressure on one side compared to the other side. The pressure down here is equal on both sides of the tube, so it's equal there and there. So that's saying that the column of air there must have the same pressure as that column of air, column of liquid plus the column of air. So for example, the liquid in the manometer below is water, and if the height equals 10 centimeters, then what is the pressure of the air flowing into the manometer? Okay, so in other words, you just have to work out, just work it out by using pressure equals rho GH.